This is a lesson on thermal properties for the Engineering Materials Science course at the College of Marin. By the end of this lesson, you should hopefully be able to explain how a material responds to heat and to temperature changes in really two different ways. First, in terms of material properties that we can measure and observe at the macroscopic level, but also from an atomic level perspective. And you should be able to rank ceramics, metals, and polymers, the major material classes, in terms of each of these different thermal material properties. Our goals here in this lesson are really twofold. We'd like to understand how materials respond to heat and temperature changes, not only because we would like to use materials appropriately based on their thermal properties, but also because we often use temperature to alter the structure and therefore the properties of materials, and we'd like to do that effectively. So let's start out just thinking about what happens when we heat up a solid material. So imagine a frying pan over a fire. So let's think about this first at the macroscopic level. Many of these things you know from your own experience or intuition. Of course, one of the first things that happens is that the material gets hot. In other words, its temperature increases. Something else we know happens, either from experience or from our previous discussions, is that the material will expand as it gets hotter. In addition, heat will be transferred from the hotter portions of the object to the colder regions. So for example, if I were trying to hold this pan in my hand and the handle were made out of metal, eventually it would get too hot to hold on to as the heat moves from the frying portion of the pan out to the handle. And depending on the temperature and the material that the object is made out of, it might eventually deform, soften, or melt if it gets hot enough. Now let's think for a moment what's happening at the atomic level. And there's really several different ways in which materials can absorb thermal energy at the atomic level, or the subatomic level. First, from our discussions of atomic structure and bonding, we remember that if you give energy to atoms, of course electrons are promoted to higher energy levels. It turns out that this electron promotion is important, as we will see, for both the electrical and thermal conductivity of materials. But it is not significant in terms of the storage of energy in materials. Rather, in solid materials, energy is largely stored in terms of the increased motion of atoms. In particular for a solid, in terms of the vibrations of those atoms, which we'll explore in more detail. And finally, another important idea about changes at the atomic level as we heat a material is that the solid becomes more disordered. Of course, an extreme example of that is when we heat a material up till it reaches its melting point, or even boiling point, at which point the atoms begin to move in a much more disordered fashion, and in the case of a gas, become completely independent of each other. But even long before we reach the melting point, it turns out that the solid state becomes a great deal more disordered as a result of increasing temperature, and we'll look at how that happens and why it's significant. So first, let's start out by just summarizing some of the fundamental thermal properties or temperature-related properties that we're going to cover in the lesson, and make sure that we have a basic understanding of what they represent. First is a property known as heat capacity that you're probably familiar with from a chemistry or physics course. And heat capacity represents the amount of energy that's needed to change the temperature of a material. In other words, it represents its resistance to temperature change. So materials with high heat capacity take a long time to heat up and to cool down. Another property is the coefficient of thermal expansion, which we've talked a bit about in previous lectures. And remember that this just represents the change in volume or length of a solid due to a change in temperature. A third thermal property is that of thermal conductivity. That is the ease with which a material transfers heat from one portion of the solid to another. And finally, a fourth category of thermal properties is phase transformation temperatures. In other words, things like the melting point and glass transition temperature, which we've discussed in previous lectures and which we will discuss in greater detail later in the course when we talk about things like phase diagrams, phase transformation kinetics, as well as when we talk about ceramics, glasses, and polymers.